All right, so in this lecture, we're going to do some practice with counting up significant figures and also with accuracy and precision. So first, let's practice counting significant figures. How many significant figures are in each of the numbers here? So the key is to look at the zeros. And in the first number, just 400 with no decimal point, the trailing zeros are not significant. So the only significant digit here is the 4. So there's going to be one significant figure in this number. In the second example, we have the 4 is significant. And since there's a decimal point, this 0 is significant as well. And we can say with confidence that there are two significant figures in that example. Just as in this example, because of the decimal point, this number, and this number are all significant. So we have three significant figures in this example. In this 400, because of the decimal point here, all three of these digits are significant. So we have three sig figs here. So if you compare these two numbers, 400 with and without the decimal point confers significance on the zeros. In this example, because of the decimal point, both the zeros before it and the zeros after it are significant. So 1, 2, 3, 4, 5, 6 significant digits appear in that number. Let's look at these examples of smaller numbers. So we have 0.0014. Preceding zeros are never significant. So in this case, only the 1 and the 4 are going to be significant. You could tell that by converting this number into scientific notation. 1.4 times 10 to the minus 3. That shows you with confidence that only this number and this number are significant digits. So this has two significant figures in the answer. By contrast, this trailing zero here, because of the decimal point, it is significant. So in this number, we have three significant figures. And if we converted it into scientific notation, we would have to keep that 0, 1.40 times 10 to the minus 3. Okay, and then that means that this number, and this number all count as significant digits. In this example, the 1 and the 4 are significant, so we're looking at two significant digits there. And by contrast here, the trailing zeros are significant because of the decimal point. So we would have 4 significant digits in that example. As another type of problem, if we have a student who analyzed a sample for calcium composition, and got the following measurements. So 14.92, 14.88, 14.91, and 14.91%. So I guess she analyzed them in quadruplicate and got these 4 measurements. What can we say about the accuracy and precision of her results if the actual calcium content in the sample is 15.70%? All right, so let's look at her data. She did 4 results, and they're pretty close to each other, right? 14.92, 14.88, 14.91, 14.91. So they agree well with each other, but they're very far from the true composition of calcium in the sample, which is 15.70%. So if you remember the definitions of accuracy and precision, precision is when you have a range of values that agree well with each other, and accuracy is how close you are to the truth. So in this case, we would conclude that the student's results are precise, but not accurate, because they are far from the truth. So they agree well with each other, but they're far from the truth. What kind of error do they exhibit? In this case, this would be an example of systematic error. She's doing it wrong, but she's doing it wrong the same way every time. So maybe it's something that's wrong with her instrument, for example. Okay, so I hope those were helpful.